St. Patrick's Day Math count. Last Thursday, March 17th, was St. Patrick's Day when typically more people than usual wear some article of green clothing. Patrick has a leprechaun hat that looks like a tall green top hat. The main portion of the hat is a cylinder that is 8 inches tall and has a 3-inch radius. He filled this portion of the hat with chocolates wrapped to resemble small gold coins to pass out to all his friends. One bag of these chocolate coins takes up about 20 inches cubed of space. So one bag of these chocolate coins takes up about 20 cubed inches of space. So what is the minimum bag of chocolate that Patrick must get to completely fill his hat? So it's talking about his hat right here. And before we understand what we're really trying to find, let's first draw the cylinder. Okay, so this is my cylinder. Okay, and we know that it is 8 inches tall. So 8 inches tall. And it has a radius of 3 inches. Oops. So it has a radius of 3 inches. And so this is our cylinder right now. Well, we need to first think about what we're trying to find. What is the minimum number of bags of chocolate that Patrick must get to completely fill his hat? Well, first we need to think about how much space there is for the chocolate, right? And that's going to be the outside of the hat. Does it really make sense for him to really put any chocolate inside of his hat? Well, I don't think so. So we're really trying to find the surface area of his hat. So the surface area. And also just saying it's not this part because this part will be attached to the part that is going to go on his head. Anyway, we first need to find the surface area. So let's first think about how we can find that. So if we first just think of this as a, say, one of those rolls of toilet paper, but without the paper, and if we just cut that cardboard and split it open, it's going to become a rectangle, right? A rectangle. So this rectangle's height would be 8 inches. So what about its length? Well, its length will be the same as the circumference of the base right here. And we all know how to fill his, and we all know how to find the circumference. That's just the diameter, which is 6. In this case, 2 times 3 is 6, times pi. So this is 6 pi, which means that the area right here is 48 pi. Now we're not done yet because we still need to figure out this top part. So we're trying to find the area of this circular part up here. So to find the area of a circle, we first square the radius, times that with a pi, and we have 9 pi. So up here is 9 pi. Now we add 48 pi with 9 pi, and we get 57 pi. So the surface area is 57 pi. Okay, so I'm going to erase this. 57 pi. Okay, so 57 pi of area. Now we know that each of these chocolate coins takes up about 20 inches cubed of space. So now what we're going to do is, besides we could actually fill pi in as 3.14. So we just multiply 57 with 3.14 and we get 178.98. And we know that each of these bags takes up 20 inches of 20 cubed inches. So we would divide this by 20, right? So that would be 8.949. So 8.949. So let's read the question again. What is the minimum number of bags of chocolate that Patrick must get to completely fill his hat? Well, we need this much, but we can't exactly take a fraction of a bag. And we can't just take 8 bags either because that wouldn't be enough. So the minimum number of bags of chocolate that Patrick must get to completely fill his hat would actually be 9 bags. Because that's just enough. So that is our first problem. Problem 2. Margaret painted a mural for St. Patrick's Day and mixed her own green paint. She mixed 3 parts yellow paint and 2 parts blue paint to create green paint. Maureen wanted to also paint a mural with the same green color, but she currently has 8 cups of green paint that is a mixture of 40% yellow paint and 60% blue paint. To get the same shade of green as Margaret, how many cups of yellow paint will she add to her mixture? So how many cups of yellow paint must she add to her mixture? Let's reread that problem. Okay. She mixed 3 parts yellow paint and 2 parts blue paint. And right now I'm starting a ratio, right? Yellow versus blue. Because if you want the same shade of green, for every 2 parts of blue paint, we need 3 parts of yellow paint. So this is actually the ratio. This is the ratio problem. Maureen wanted to also paint a mural with the same green color, so same color, but she currently has 8 cups of green paint. That is a mixture of 40% yellow paint and 60% blue paint. So 40 and 60. So 40 and 60. So that simplified is actually 2 and 3. 2 versus 3. So to get the same shade of green as Margaret, how many cups of yellow paint must she add to her mixture? So right here we have Maureen. So this is what Maureen currently has, right? And she wants to get this ratio to be here. And we're just thinking of how much cups to add to her yellow. So let's think about what this ratio would look like if it had 3 parts blue paint. Okay. So this is 3 3 to 2 is equal to 1.5 to 1. And that makes it equal to 4.5 to 3, right? Because we multiplied a 3 on both sides. So we're just trying to get 2 parts to 4.5 parts. So we would do 4.5 minus 2, and we have 2.5. So that means we need 2.5 more cups of yellow paint to add to her mixture in order to get the same shade of green as Margaret. So it's just a problem of equivalent ratios. So 2.5 cups of yellow. Okay. Now she will have the same ratio as Margaret. Okay. Problem 3. Now let's take a look at the word green. There are not too many real words that can be made from the letters in green. For this problem, though, let's see how many ways we can arrange the 5 letters in the word green, even though they don't form real words. But let's also add a restriction. Any arrangement must keep the 2 E's together. So how many arrangements are there? So first, we look at how much spaces will it be in green, right? There's always going to be 5 letters, so I'm just going to write 5 lines for the 5 spots that the letters are going to go into. So we know that there are 2 E's, right? 2 E's. And I'll name them E1 and E2. So they always have to be together. So this is one possibility, right? E1 is first and E2 is second, or E2 is first and E1 is second. This is another another variation that it could be. So for that, we need to express that as A2, 2, right? Because out of these 2 possibilities, we're just choosing 2. And we multiply that, and we're just going to see the rest, right? The rest after the 2 E's, there's just 3 letters left, which is G, R, and N. So we just want to see G, R, and N out of these 5 places, what 3 we can get out to find the places that G, R, and N are going to go into. So out of 5, we're going to choose 3. So we just multiply these 2, right? Which equals 2 times, and this is just equal to 5 times 4 times 3, and that equals 60. 2 times 60 equals 120, so there are 120 arrangements. So thank you for watching Through Inquisitive Kids, and see you next time.